So I don't know how many of you have a project which looks a little bit like this, where somebody's coming to you and saying like, hey, you know that application we have a new requirement we would like to add to it. And so maybe at first it started out very simple and it was just like one of these plugs. So it looks very simple. It's like one of these plugs, and people are just sort of plugging in a few things. But as time goes by, it gets harder and harder to keep adding features. And part of that is because we haven't changed how we look at design. We're still trying to apply early steps that we did when we first built the application. What happens is we end up in this situation where we're in a never-ending stabilization phase. Developers are, when we first start out working on a new application, it's really only, it's easy. It's version 1.0. And so we just have to deal with, getting our requirements analysis and coding, but the cost of making changes isn't so high, and it's too bad. But the problem is later on, when we start wanting to make more adjustments to our code, it gets harder and harder because the design isn't quite matching what the new market requirements are. Another thing that happens is, like those plugs you saw at the beginning, is that the design is no longer supporting our new requirements. And so it gets more and more expensive to keep adding features. When we start talking about new ways of software delivery, like continuous delivery, we need to start thinking about a lot of things. We need to start thinking about activities that support that, such as a way to do functional testing, a way to do unit testing, and a way to automate our deployments. If we don't solve these problems, the continuous delivery actually costs us a lot of money and time because of the manual intervention needed. So if we're still doing manual testing, or if we're still doing manual deployments, it's very difficult to do continuous delivery in an economical fashion. So what we need is a way to keep the cost of change flat, so that over multiple versions of our software, over the years that we use our software, that the cost won't be increasing every time we release the software. So this is called the extreme programming, the XP cost of change curve. And extreme programming comes with a bunch of technical practices, test-driven development, some kind of macro testing such as BDD or system testing, and continuous integration in order to keep our cost of change low. The cost of software ownership. If we think about version 1 of our software, that's just to get started. But when we want to add more features to it, we will always be increasing the cost. So when we think about the total cost of ownership of software, there's the cost of creation versus the cost of all of the multi-years that we keep the software around. What is the percentage? Go ahead and think about this a moment in your head. Think of some numbers. So those two numbers should add up to 100%. It turns out the cost of creating the software is very much a small piece. The cost of maintenance is much higher. And this makes sense when you think about it. That version 1 of your software, even though it seems very difficult because it's new, it's maybe highest risk because we know the least about at the beginning of a brand new application or project. So this makes sense because there's just one version. And then you have multiple years of using and maintaining, either bug fixing or adding new functionality, that the cost of maintenance is really the largest piece of economics or the cost that an IT organization undergoes. Well, think about the cost of maintenance for a moment. If the cost of maintenance is 80%, let's break that down further. Let's think about different aspects of maintenance. There's the effort of writing the software, and then there's the effort of reading the software. If you look at that 80%, what are the two numbers that would fit into the effort of writing software versus the effort of reading? So go ahead and think about that in your head a moment. Think about what percentage of the effort do you personally or do your teams spend in writing the software versus just understanding the existing software. So for most projects, the effort of writing the software is quite low. The effort of reading software is quite high. So what your teams do on a daily basis, what software developers do on a daily basis, is they actually spend a lot of time reading. We're really readers, not software developers. We're trying to understand the code, understand the logic, in order to make some change that was requested of us. So this goes back to, we have to ask ourselves, well, what is the primary purpose of source code? Why is it that we have source code? What is its purpose? So what I have here is I have, 3 snippets of source code. I have this section down here, this lower right. That doesn't look probably much like source code, but it's valuable. That's what the computer actually looks at when it executes the code. We can go a step higher up, and we can look at the assembly in the upper right quadrant, and you can see that, well, it's still pretty hard to read. We have some memory address locations on the far left, and we have some kind of register references, and then we have some commands. We're starting to get a little bit closer to English, but it's still very, very, very difficult. The effort of reading this software to make the correct change would be pretty high. It'd be less than this one down here, which is the only version that the computer requires. And then if we go over to the code on the left, we look at something simple. It's just hello world. That's very easy to see and understand. So the effort of reading that software would be much less than those other two. So you can see that the primary purpose of source code, if you understand this, you'll be able to make good decisions about sustainable design. The primary purpose of source code is so that the human beings, the people, the developers, can understand the code as it is. And they want to be able to understand it in order to maintain it and all those other good things. Now, if the primary purpose of software is to make it readable so that we can keep the costs of that low, so that maybe we can get closer to spending more time creating software rather than reading it. Well, let's find out what gets us into a situation where, like you saw on the very first slide with the electrical plugs, how do those things happen? Well, on the first case here, we have take a look at some of these causes. Sometimes we just either the design was perfect in version 1 of the software, but by version 10 or 12, we keep adding features and adding features. Pretty soon the design doesn't actually match what it needs. And so when somebody's asked, or the business says, hey, please make this adjustment, we're going to offer this new product, go ahead and add in this new functionality to support that, it starts taking more time to add those features. So we're starting to pay that cost. We don't have the flat XP curve. The other thing that slows us down is that middle bullet, code is confusing. If it takes a lot of time of reading and rereading, it's just going to be hard to work with, and it'll be easy to create bugs. The last one, lack of test automation. What that means is that everybody knows, or your development team knows, that the code isn't easy to understand, and that they actually may even know how to fix the design, but they don't do it because they're not confident that they can make that change. So they leave it as is. They go ahead and spend lots of time reading code in order to make changes. And a lot of these changes that people make in the industry, when I go and I visit a company, it doesn't matter if it's in China, India, or the US, it's the same story. When they go in and make these changes, it really is it frequently is only a few lines of code changes, but those few lines of code changes take hours of reading and study to understand how to make that change, because the design doesn't match. There's a little more on why this happens. In the upper left quadrant, we have, sometimes it's deliberately means we made a decision not to take time to make a design. So it's a little bit deliberate recklessness, where we are pushed. Maybe we have a trade show to get ready for, or maybe there's a big customer who says they'll pay for we're a startup company and we have only one customer, and they push us to meet a deadline that's really difficult. And we decide that, we're just going to start coding it and see what happens. Now, I'm not talking about going back to waterfall, but this is a bit reckless when we don't even know or pay attention to, what are the features, how do we build for those features? If we spend zero time at it, it's a bit reckless. Sometimes it's in the far right, upper right quadrant, where it's deliberate but prudent, meaning we really need to ship something for whatever reason, and we're conscious that it's not the best idea. We're conscious that our design doesn't quite match, but we'll go ahead and do it because we'll fix the problems later. Of course, if no one actually fixes the problem later, you're not going to have a flat XP curve. If you're not doing any test automation, if you're not doing any refactoring later, you're going to end up having software that's going to reach an end of life very soon because the design isn't sustainable, or the process of creating design and software isn't sustainable. In the lower left corner, we have sometimes we all have something to learn. So we inadvertently build things incorrect because we just didn't understand maybe the best way to design it. Maybe the very first version of the software, the feature was very straightforward. We got it built and delivered and everybody's happy. But by version 10, we keep tweaking this and tweaking that, and pretty soon that same class, the same class that was maybe only 20 lines of code is now 500 lines of code, and it's a bit of a mess. And maybe we could have solved it with some design principles, such as using a good class hierarchy, some super classes, and to make the design understandable. But we didn't know how to layer that, and so just because the development team didn't know how to do that, it didn't have the best design that it could have. And this happens. We could look at the new functional features that are being added to languages now. Those features sometimes can make your code easier and more maintainable if you know how to use them. Sometimes they can make your code harder to maintain if nobody else on the team understands them. In our industry, we're always spending time learning new things. In the far right corner, maybe we knew we're good software designers and the team knew what to do, but again, it goes back to that the first version of the software was simple. The design was simple. It was the right design for the time, but after several versions later, we realized, oh, wow, the business keeps asking for this type of feature and it keeps asking for changes in it. I think we need to approach this differently. Maybe we need to extract. Maybe we need to stop driving this through writing computer code and making it more of a configurable situation, such as maybe marketing is always changing something in the content. Oh, okay, we could use a content management system instead of writing the content in our application. Debt is created by trying to understand our market and trying to understand how our code is working. Now, what does this have to do with the Agile? So when we think about the Agile processes, the Agile Manifesto points out some hints about why or how we should keep ourselves out of having high technical debt, because that high technical debt is going to ruin our ability to have a flat cost of change curve. And I highlighted a couple points here. So when there's Agile processes, promote sustainable development. So sustainable means that we can keep changing the software for years and years and years and at the same pace. So that might mean version 1 of the software could be done really fast and released to the market maybe 20% quicker if we skip a bunch of stuff. And if that stuff's like unit testing or macro testing of some kind, like behavior-driven development or some other system testing, then we're going to not be able to maintain that pace indefinitely because version 1, we had the fewest set of features to manually test. And version 2 is going to have more features, and version 3 is going to have more features. So if we start out short shrifting on version 1 and we don't change quickly, we're going to end up with a situation where it's going to get constantly worse and worse, and it'll be even more expensive to fix it later. So we're completely fitting not the XP cost of change curve, but the first one, which frequently is brought about by waterfall style practices where quality is done at the end of the process rather than at the beginning. The next bullet, continuous attention to technical excellence and good design enhances agility. I don't think anyone would really argue with that. The question is are we doing continuous or not? Every sprint, are we thinking about or measuring if our design of our application, is it getting better or worse? Every time a developer looks at your code, when you have somebody doing work, do they do any improvements at all, or are they just living with the problems? So what this means is are are the practices of the team, are they spending time continuously looking and thinking and reflecting about their design? And I don't mean like this has to be a long drawn out process. It's like, this is what I see when I work with developers. So I pair program with developers all over the world. And so we frequently look at the code, and we'll look at something and it'll be confusing. It won't be supporting the needs of the humans. It'll just be code that compiles into something the computer can execute. And so the developer will say, you know, this is what this function does, and he starts telling me verbally what it does. And he's explaining some of these variables, and some of these variables will even have like single letter or 2 or 3 letter names, which nobody would know, except that if you work on the project for like 5, 10 years, then you'll kind of be able to figure out the hint. But he can figure that out, and he can explain it to me. But if we're going to pay continuous attention to technical excellence and good design, we're going to, as soon as he starts explaining something to me that the code should already tell me, we start changing those variable names so that it's clear. And then after we do that, and these are things that don't take that much time. And then we check in that code, and that becomes an artifact that's captured for everybody else in the team to leverage, so that the code's more clear for everyone else, rather than having to spend time reading it and then explain it, which, you know, we're not recording these conversations in our source code. So you can see that if it requires a lot of explanation, if source code requires a lot of explanation, the design could use some more. So when we see problems in our software, we need to start talking about, you know, how to fix those problems. And this is a great book, the Martin Fowler book on refactoring. You know, this is going to probably sound like an advertisement for the book, but the thing is, this is the best book I found. So I've had this book since 1999 or 2000. I got the copy of the book. And ever since my team and I, we learned this. We went through the whole book, and we learned all the refactoring patterns in there, and we learned all the code smells in there. That knowledge has been useful throughout my whole software career. So I really can't emphasize how great of a book this is for your team to learn how to learn from. When I coach teams on refactoring, I use this book as basically my teaching materials. I try to encourage teams. I encourage teams to buy a set for the team and then start learning from it. I'll talk more about that later. There are other books on refactoring, and I've tried a couple, but I felt like I haven't been as happy with them as I am with this book. Let's talk about what is this word refactoring, because a lot of you probably have heard it at work. Maybe it's brought up frequently, but you have to be careful here, because some people, when they say the word refactoring, they just mean software development. So we need a clear definition so we know what it means. So there's a function. By the way, refactoring also comes from math. So there's this function which has 9x cubed plus 6x squared plus 3x. And beneath it are 3 different versions of that function. Now, what refactoring means is that function works the same way after the refactoring means the function should work as the same, the results of the function should be the same as what you see on the original format versus those next 3. I don't know how long it's been since you've thought about math. You know, our university days might have been a few years behind us, but one of these is not correct. So if you pass in x in this function, you won't get the same result as the original, and that's an incorrect refactor. Perhaps that was a new feature change, and perhaps that's what the business wants, but it isn't a refactoring. So refactoring is when we're just changing the design, but we're not changing the functionality. We're changing how the code looks, we're changing the naming, we're changing the class structures, but the result of the functionality is the same. So, you know, why would we do this? And I don't know if I've convinced you yet about this, but think of this again goes back to the primary purpose of source code. And if you're spending time looking at the code to understand it, other people on your team are going to waste that time too. So you're actually speeding up your team when you start solving these problems. It may take an extra 10% of whatever it is on your task to do that, but that 10% is something that's checked in, and that will be an artifact for the future, and that will improve, and the next person, when they look at the same functionality, they may improve it further. So Another sign of when you should refactoring is when you can't actually write a new test for the story you're implementing. There's something wrong with your design because we need testable designs as well. Otherwise, we can't have a flat cost of change curve. That flat cost of change curve is so important to businesses, especially when people are wanting to move into continuous delivery. If you can't get a flat cost of change, you can't do continuous delivery. It'll cost you too much, okay? And of course, you might refactor when you realize, hey, every time I have to add new functionality, this functionality the business is asking for, maybe the business is funding some new project, you're gonna discover, hey, maybe this design doesn't actually support that. So we'll have to refactor the code. So the main thing is if you're going to be that agile developer who values what we talked about in the manifesto, where you're continuously improving your design, you just start fixing problems as soon as you see them. Now here's a picture of a hero right now looking into a fridge, which is filled with source code, if you will, and something smelly in the fridge. Something is really powerful, and now the hero has to put on a gas mask because they don't want to get knocked out by the smell from the code. And here's a list of common code smells. Take a look at that and think to yourself about your own source code, about duplicate code, that you have functions or methods that are too big. There's going to be some in there that you probably aren't even aware of, like comparing variables to null is a code smell. Or if you look further down here, switch statements, they're a code smell. Okay, and this might be rather shocking to you, because it was shocking to me back when I learned this back in the early 2000s about switch statements. Switch statements are a code smell because every time you create a switch statement, you have to add more cases, and when you have to add more cases to your switch statement, the code keeps growing and growing in complexity. It isn't a sustainable pattern. It could be sustainable if there's always ever going to be, like, say, 5 cases, but the problem is that's rarely the case. So some of these code smells you may say, yeah, I totally agree with these, and some of these code smells you look at and you're going, whoa, what's this about? These code smells come from the Martin Fowler book. So now the hero has to do something about those code smells, and what you do to solve those code smells are using some of these refactoring patterns to clean up the problems. So there's a technique called extract method about taking a really large method and breaking it up into several small methods. And then there's the opposite. Maybe you have several small methods in your code, and it's not sensible to have such small methods, so you go ahead and inline them to make it a larger method. So every refactoring step has an opposite, and we'll talk more about why you might have to do sometimes you do use extract method, and sometimes in the next 10 minutes after you're doing it, there's a couple things you'll realize, you know what, I actually think those 2 out of those 10 methods I just extracted really should be in line, so you'll back up and inline them. Here's kind of a simple blow-by-blow example. We got to keep it simple so we can get this webinar done in time. So this comes from the book as well on refactoring. We look at this function called print owning. It's going to take some amount, and it's going to print a banner, and it's going to print these 2 levels of details. So one of the points here is when you see a comment like print details, that's actually somebody is screaming out to say this, hey, my design no longer really supports the human readability, so I'm going to put a comment in there. A comment isn't a design artifact, however, that's just a comment. So in order to solve that problem so that we don't need to comment the code and make the design stand up and be clear about what its purpose is, you just see this refactor method where it says print owning again, double the amount goes in, print banner stays the same, and now it just says print details and passes the amount. Now print details takes those 2 calls, extracted them into a print details method, takes the amount, and then it does exactly the same thing. It does exactly the same thing because it's a refactor. We're not changing functionality, we're just changing the design. How do we do this without creating bugs? That's important, right? Well, the first step when you want to refactor some code, like we just saw over there, though I'm sure yours will be a little bit more complicated than that, though sometimes it isn't much more, and sometimes it is a lot more. But the main point is if we can't even be bothered to refactor simple things, then we're not going to ever be that hero. So don't be shy, fix simple things too. But before you change anything, go ahead and run all your automated tests. And I hope they're automated. If they're not, that might be another problem you need to solve. And we'll talk about how to refactor without automated tests too. But run all your, typically I run all the micro tests. I don't worry about macro tests. Micro tests are unit tests. Macro tests are things that test the functionality rather than class objects. So I run my micro tests because they're really fast. Okay? If I have good code coverage with my micro tests, that's what I do. I run all my micro tests. And then I want to make sure they're all green. If they're not all green, they're not reporting back green, then I know there's a problem to fix before I even start the refactoring. So now I'm refactoring because there's a problem with something, whatever that problem is. That problem could be I don't understand the source code and I spent some time reading it. Maybe I spent 30 minutes, maybe I spent 15 minutes, maybe I spent 5 minutes. And I see, wow, there's a couple of things I could do to make this code easy to understand. You know, maybe it's something I can fix in 60 seconds. Maybe it's something I can fix in 2 minutes, or it could be a really tough problem. It could be that really giant case statement with 10 cases, and the method is now 1,000 lines. Okay, so that's a big one. So anyways, I know there's a problem. There's something I want to do. There's a goal I want to achieve. So now I think about this. Okay, maybe it's the case statement. So I can either I remember this, or I go grab the Martin Fowler book and I read up on that, the 3 pages it talks about on the switch statement smell, and then I refresh my memory on some things, and then I think, okay, I'm going to extract method. So I'm going to extract some methods, a lot like what you saw in that other code example. Maybe I highlight one whole case and I extract that into its own method. And so anyways, I apply that, I extract the method, maybe I use my IDE and it helps me some. And then when I'm finished with extracting that one method, I go ahead and run all the tests again, because what should happen? Think about this. Should the tests pass or fail afterwards? I hope you're telling yourself, yes, they should pass, because there shouldn't be any changes. The same thing should be happening as before. All right, so step by step, I'm going to do these, and I might apply this several times before I solve a big problem, like it's a 10 case switch statement. I may want to apply this 10 times. I want to extract each of those case statements into a separate method. And then if you read the Martin Fowler book, you're going to see that, oh yeah, the next step after that is to move those methods in their own separate classes. And then once you do that, you can get rid of your switch statement. And that allows you to have a very sustainable design, because you can just add new functionality by adding new classes rather than continuously editing the switch statement. Okay, so each step of my refactorings, I do these steps. Now let's talk a little further on, let's look at a conceptual on why I might do a refactor. So look at this nice man here. He's working in a kitchen. And he's working in a kitchen just like you guys, everyone on the call here, software developers. You guys do you work alone, or do you work with a group of people? Are you working together to build something new, or are you working separately? So if you're like this fellow who doesn't look too happy, something's not working well, and he's upset. So somebody probably put something in the wrong spot, and he can't figure out how to finish his job. You can't figure out how to, maybe the forks are in the wrong place. Who knows? You can tell he's not a happy man. So let's look at some conceptuals on why you would become unhappy looking at code that you're sharing with a team of people. Here are some shots of my kitchen, from my kitchen in China, and I lived there 6 years. And so you see in this first shot, look at that. Tell me what you see. I know I can't hear you, but just tell me what you see. Say it out loud. What do you see there? Can you tell really fast? Do you have to spend a lot of time studying it? Or do you have a pretty good sense quickly? Okay, so hopefully you're saying to yourself, I see bowls and plates. This next shot, what do you see? Do you see bowls and plates? No, you see some coffee cup and some glasses. Okay, this next area, starting to get a little harder, right? You see some cans to some materials. If you read Chinese, that's baby milk. And then you see off to the left, there's some some kind of silverware, probably knives, and a ladle. Wow, okay. Now, if I invited you over to my house and said, hey, can you help me wash the dishes? You know, let's work together on something. You say, great. You start washing dishes, drying them, and you think, wow, okay, where do I put, you know, how do I put things away? Where do the cups and bowls go? Where do the glasses go? Where do the knives go? And then you might even see more complications like this. Wow, there's some plates there, some chopsticks, and some silverware. So now the problem is if you have a plate, which section of this cupboard does it go in? Well, I guess you're going to have to go find somebody and consult with them. Maybe find an analyst, maybe find another developer and say, hey, I need to add another plate. Where does it go? Does it go in this spot, or does it go in this other spot? So there's a problem. The design no longer is understandable, right? So how do you feel? Chances are you feel a bit like this nice man. He's usually a nice man, trust me, but he's frustrated because he can't figure out what his next step is. Something's getting in his way. The design isn't clear. If people don't fix up the kitchen, it's always going to stay a big mess. Now, I hope you get the sense now that if we keep our code organized, we know how to work without going through a lot of trouble, spending a lot of time reading, spending a lot of time consulting with other people. I'm sure some of you probably don't have good micro tests. Maybe you don't have good code coverage with your unit tests. So in these cases, you still can do refactoring. You just have to use lower risk refactorings. You can't maybe jump to something too complicated, but if you do several simple things, you can actually improve the code design quite a bit. So, you know, rename those variables that you can't figure out. If you had to figure out for more than 20 seconds what a variable name means, it's a bad name. Go rename it. Extract method. So sometimes you can't, extract method, it's possible to go wrong, but most people will be able to handle this quite well. If you're extracting case statements with breaks or continues, you have to pay attention to that and support that behavior. So it's always, we're all developers here. It's possible to put bugs anywhere, and we seem to be very confident in making code changes the business asks us to do, but we're less confident for some reason in doing changes that also support our design. So one point is that last sentence there on the slide. Is that when you don't have unit tests, you want to keep your steps still pretty small. You want to make several small refactorings and prove they work. So think about the experimental process. Think about lean minimum viable experiment. Change something and then test it some way. And if you don't have unit tests, you're going to have to walk through it with a debugger, or you're going to have to exercise it running by deploying your server and executing the code. And if you're in that case, I recognize you're going to do less refactoring, but you still can do some refactoring. If you're doing zero refactoring, you're making the wrong call, and you're always going to have a messy kitchen, and you're going to have that angry chef man, and they're trying to figure out where things go. So we want to go from this, using techniques such as extract method in class, using some of these things to clean up our code. And we want to end up with this. You want source code where people can figure out how to work with it, where the humans can understand it. Now, refactoring is a little bit, it isn't a straightforward process. You might see there's this game called Mikado, and it's also called Pickup Sticks in the U.S. I don't know if the folks in India have the same kind of game, but you make a pile of sticks. Ideally, they have a little bit different colors, or at least one's a different color. And you can see this stick right here, this black one's called the Mikado stick. And the goal is to, how you play the game is you have like 5 people show up, and you say, hey, who can remove this black stick without making any of the pile move? So if you're lucky and that black stick's on the top, you just take the stick off and you're done, right? That would be an easy refactoring. One person picks up the Mikado stick, simple. Sometimes you spot this problem, this Mikado stick, and you have to do a lot of small steps of refactoring before you can actually get to that stick. So you have to think, well, let's see, I'm going to take this blue stick here, and I'm going to lift that off, and you lift it off, and if nothing in the pile shifts, good. That's your feedback mechanism. There's no problem so far. And then you think, okay, I'm going to remove this red stick here, and if you can lift it off and nothing in the pile shifts, you still get to keep going. And then maybe you try to move this, see, this white stick's pretty tough because there's a yellow stick on top of it. And, oh yeah, we can probably move that yellow stick, but oh, you didn't notice that this white stick here is also on top of it. So when you pull this yellow stick out, the pile shifts. And by the rules of the game, you've done a bad refactoring. All right? But you couldn't predict that. You couldn't predict all the steps in advance because our minds can only see, you know, maybe 5, 6, 7 steps into a refactoring in advance. And we're guessing at some of those. We don't always know they're going to work out. So the key is like the Mikado game, is to pick up one stick, make one step in refactoring, extract one method, and then ask the computer, hey, is everything okay? And you do that by running your unit test. You would never be able to do this. Hey, can you write a plan? Hey, developer, can you write a plan that helps me, that allows me to refactor that? Write it up in a plan with all the steps and have it correct. It's too complicated. It would be very hard to write down the plan. If your plan was going to have any chance of success, you have to spend more time analyzing it than it would take just doing it. And even after you analyzed it, there's a very good chance that something's going to change in the system that you didn't foresee, that there's some dependency you didn't foresee, and it won't work. So it's better to work with a live system and take several small steps. So the key point is the cycle happens quickly. That means when you do a refactoring, it shouldn't look like this. Hey, I came in at 8 o'clock in the morning, I ran all my unit tests, at 8:30 I started refactoring, and the code didn't compile until 4 p.m. Okay, so that is really too slow. The cycle will take forever. At 4 p.m., when you get the code to finally recompile, maybe you made so many mistakes that you'll never be able to get the system working without spending like 2 more days. Better to be doing something like this. Hey, at 8:30 I started refactoring, and at 8:45 I ran the unit test, and they passed. And so then I made my next move. At 8:45 I made my next move, and at 8:50 I ran the test, and that move worked too. And so you keep moving step by step by step. Just like if you were to walk from Bangalore to New Delhi, you're not going to be able to jump there all the way in one big step. You're going to have to take several small steps. And sometimes you're going to make the wrong turn and you'll have to back up. So you need a system that tells you when you make the wrong turn as soon as possible so you don't waste time. And those are your unit tests. The Fowler book will do a great job on leading you through how to do that. Sometimes I'm in a situation where the business asks me or the person I'm working with, that I'm consulting with, to make a change, to make a new piece of functionality, and it requires a big refactoring. And one of my favorite bad guys, code smells, is switch statements, because I find that if you have an application that's at least 2 or 3 years old, those switch statements would generally have outgrown their ability to be helpful. And so think about this. If you have you just describe, maybe you only have time to fix one case of that switch statement. And so now you need to leave a little bit of something. You need to put some information behind for the next developer so that they know why, when they look at the code, that the switch statement looks like a normal copy-paste store to switch statement. And then there's this one case where you started refactoring, where it's now not just a copy-paste case statement, but it's now going to call into a class with a function. And you did that because you didn't have time to fix the whole design. You maybe only had time to fix, you know, like I said, maybe you only spend 10% extra time on what, if you're going to spend 2 hours to add the functionality, maybe 10% of that time is used to refactor. Maybe 50% of the time is used to refactor sometimes, but sometimes I don't have the luxury to spend a lot of time refactoring, so I spend a little bit of time. And then in those cases where I left a class that's partly refactored, I need to leave some information behind for the next person so that they can carry forward the good work. We want to have visible results. So we don't want to just refactor and have the code not get better. So if you have something like Sonar Cube or some kind of static code analysis, it's nice to give the team feedback so that they know that the process that they're using is getting good results. Their files are getting shorter, it's easier to read and maintainable, there's less static code analysis violations. You want to see a project like this. You may not be too familiar with Sonar, but in that upper picture, you see that there is a technical debt, and it's over 4 years, and you can see it was climbing, and then it started going down and down and down. You want to see the team improving the design every sprint. You want to see some kind of improvement. Doesn't have to be big, but there should be some kind of improvement. So when's the best time to refactor? That would be as soon as you see a problem. If you can go ahead and think to yourself, audience, you know, what are the, can you think of 3 code smells? Can you think of 3 code smells maybe in your code? The next one, what do you think? It's most efficient to refactor while adding functionality. Is that true or false? Technically, it's false. You never refactor while adding functionality. You may get a user story for new functionality. You may start going into the code to add the new functionality, but then you see, oh my goodness, I need to fix this problem. And you want to just fix the problem first in a step by itself by cleaning up the code smell, using some refactoring. And then when you're done with that, you go back to adding new functionality. Your refactorings are there to support adding new functionality, but just don't do them at the same time, otherwise you end up with a mess. People lose track of what they're doing if they try to do both at the same time. And SonarQube's a great tool to get visibility into technical debt. So now how do we get this working? How do we get started on this? You want to make your smelly code visible using some kind of information radiator. Show something from SonarQube on some frequency, at least once a sprint. You want to teach your developers how to refactor. You should give them something to learn refactoring from, like a book. You want to get your development staff, your technical leads, you want them to learn how to do this too so that they can mentor them. And you want to remind your teams to follow, you know, the principles, the Agile principles of continuously improving. One way that we did it is we created a coding book group where we meet once a week. Ahead of time, one person on the team picks one refactoring pattern from the book to demonstrate to the group and then demonstrates it. So we met once a week for an hour. Somebody prepared ahead of time one of the refactorings and demonstrated it in code, not talking about it, but doing it. Because refactoring is kind of like math. You can't learn math just reading the book. You have to get out the pencil and paper and start, you know, using math. So you want to use your refactoring, and I recommend just doing it in your source code rather than using some kind of lab examples. And then at the end of that book group meeting, you run your tests, and if the tests all pass and everybody's happy with the results, you check it in. That's a very powerful book group because now you're doing work, you're learning something, and you're learning by actively doing. So think about how you can support learning in your organization, and in this case, refactoring.